Hi everyone, welcome to our presentation. To kick things off, we would like to ask you a question. What if you could print a custom jet engine part, a medical implant, or a shoe that perfectly fits your foot, all from a digital file? That is 3D and 4D printing, and it is already changing how businesses create, deliver, and capture value. Today, I, Swapnali, along with my teammates Jignesh, Kartikeya, Priya, and Dini, will walk you through the world of 3D and 4D printing and how these technologies are transforming modern businesses. Traditional manufacturing is subtractive. You cut material away, wasteful needs, expensive molds, requires minimum orders. 3D printing is additive, builds objects layer by layer from a digital file, no mold, print 1 or 1 million at the same unit cost. Materials range from titanium, metal, plastic, ceramics, and even living cells. There are three types of 3D printing. The first is fused deposition modeling, which melts plastic and builds objects layer by layer. This is the most common and it is used for prototypes and consumer products. The next is stereolithography, which uses UV light to cure liquid resin into highly detailed shapes, commonly used in dental and jewelry industries. The third is direct metal laser sintering, which uses laser to fuse metal powder into strong complex parts. This one is especially important because it is widely used in industries like aerospace, medical devices, where precision and durability are critical. Now, looking at the market, 3D printing is one of the fastest growing manufacturing technologies today. The market is projected to go from around $28.5 billion in 2025 to over $134 billion by 2034, showing massive global adoption. It is already used across aerospace, healthcare, fashion, automotive, defense, construction, also because of the business advantages like speed, hours, not weeks, cost, no molds, no minimum, customization, unique product, and mass production economics. Up next, Dini will walk you through 4D printing.
Hi everyone, my name is Dini, and in this slide, let's talk about something interesting. Now, imagine this: what if something you printed could change shape after it's made? That is called 4D printing. It is basically 3D printing, but the object is designed to change its shape or function over time. So instead of just creating a fixed object, 4D printing uses smart materials that can react to things like heat, water, light, or even electricity. When these materials are triggered, the object can transform by itself. What makes this interesting is that there are no motors or moving parts. The change happens naturally because the material is already programmed to behave that way. This idea was first introduced in 2013 by Skylar Tippett at MIT Self-Assembly Lab. In his first experiment, he created a flat object that could fold itself into a 3D shape when placed in water, completely automatic without any human help. So there are already some amazing real-world applications for 4D printing. For example, researchers at the University of Wollongong developed a 4D printed water valve that can open and close by itself depending on the temperature. And in healthcare, there are medical stents that are inserted into the body in a small shape and then automatically expand at body temperature. So patients do not need another surgery. And in aerospace, engineers are developing drone wings that can change shape during flight to adapt to different conditions. In terms of the market, 4D printing is growing very fast. It is expected to grow from about 650 million in 2025 to 4.1 billion by 2030. This means 4D printing is a fast growing industry with huge future potential, driven by its ability to create smart and self-changing products. This shows that 4D printing is one of the advanced innovations that industries seek.
Hello everyone, my name is Jignesh Malodia and I'll be talking about mass customization, one of the key business model patterns being transformed by 3D printing. Business model patterns are basically standard ways companies create and deliver value, and 3D printing disrupting several of them. Traditionally, manufacturing involved a clear trade off. You could either produce products cheaply at scale or customize them, but not both. Mass production is efficient because everything is identical, but customization becomes expensive because every change requires new tool, new molds, and new setup. In traditional model, companies can produce cheap and identical products very efficiently, but once you try to personalize, cost increase significantly. With 3D printing, this completely changes because products are created from digital files. You can modify the design without changing the production process. So now businesses can offer products that are both customized and cost efficient at the same time. This shifts the model from supply economy of scale to demand economy of scale, where value comes from meeting individual customer needs. This shift is already happening across multiple industries. In healthcare, custom prosthetics can now be scanned in the morning and fitted the same day, reducing production time from weeks to just hours. In dentistry, millions of aligners are produced every year, and each one completely unique to a patient's jaw. And in footwear, performance insoles are customized to an individual's biomechanics, yet sold at a similar cost to mass production products. So what are we seeing is simple. One person, one product without increasing cost. So what does this mean for businesses? According to McKinsey, competitive advantage is shifting away from companies that simply produce at scale and towards those that understand the customer better and create superior designs. In other words, value creation is moving from being product focused to customer focused, and 3D printing is what makes this shift economically possible.
Thank you. Hey guys, this is Kartikeya Yalamanchili. Now we have seen how 3D printing breaks the cost versus the customization trade-off. Now I'd like to show you the second major business model transformation which enables, and also it is very much arguable and also disruptive. This section covers majorly two closely related patterns. One is the platform model and the other one is subscription as a service model. These are the two distinct patterns, but 3D printing activates both at the same time. We'll explore both of them together. To understand why this matters, think about what happened to music. We had been shifting from physical CDs to Spotify right now. That means we have stopped owning a product and started accessing a service. Something very similar is now happening to manufacturing. Instead of shaping a physical spare part or purchasing it from a warehouse from other part of the world, you simply download the digital file and print it locally. The product becomes digital, the supply chain becomes a platform. As we know, this is shifting from pipeline to platform and from controlling the resources to orchestrating them. There are three new business models. Let me break this down into three concrete submodels that 3D printing has been made possible. The first one is printer as a service. Companies like Stratasys and HP, they are not just selling the 3D printers, and they are offering printing capacity for the subscription you pay. You pay for what you use and not for the hardware. This is a classic service pattern. It shifts revenue from one-time hardware sales to recurring income stream. It creates the platform lock-in because the customers use their own workflows around one provider's ecosystem. In business model terms, this is primarily about capturing the value, recurring revenue, and long-term customer retention. The second one is digital spare part hubs. Companies like Airbus and Caterpillar, they're replacing physical warehouses full of spare parts with digital file libraries. Instead of storing thousands of components globally, they simply print parts locally on demand wherever it is needed. This directly transforms value delivery and makes the time delays to zero, and nearly it also drops the inventory costs to zero. There is no single point of failure. This is what known as inverted company concept. The production moves inside to distributed external sites. The third one is manufacturing of marketplaces. Platforms like Shapeway and Materialize act as two-sided marketplaces, connecting designers and customers one side with the local print hubs on the other side. Shapeways alone has facilitated for the production over 10 million parts for independent designers who have zero factory infrastructure of their own. The platform owner does not manufacture anything, they orchestrate the ecosystem. This is the pure value creation through platform network effects. The more designers join, the more customers come, and the more value the platform becomes for everyone. Now, let's look at the numbers because the market data confirms that the shift has been already happening in a large scale. The 3D printing service segment, which is the platform and as a service proportion, specifically is projected to grow from $23 billion in 2024 to $88 billion by 2030 at a compound annual rate of 23.5%. And critically, services are growing faster than hardware, which means that value is shifting away from selling printers towards owning the platforms, the designs, and the customer relationships. I want to be clear about these figures. This is the services and the platform segment of the market. Our earlier slide has showed the total global 3D printing market, which includes hardware, software, and services combined. These are complementary data points from different cuts of the same industry. And this brings us to the most important strategic insight of this section. Competitive advantage is no longer about who can manufacture the cheapest. It's shifting towards who owns the best designs and the deepest customer relationships. As a scientist direct has been noted in 2025 that platforms or the firms that will win are not the ones who will build the biggest factories, but the ones who build the most valuable platforms. The final slide for my section captures the transformation visually, and it maps directly onto our frameworks which we had been already known and studied. The old pipeline model ran in one direction with one flow from design, manufacture, warehouse, ship towards customer again. Every step was controlled internally. It relied on supply economies of scale. You had to make things in large volumes to keep the costs down. it had fixed costs which are very high and a single direction of value flow. But the new platform model enabled by 3D printing looks completely different. A centralized digital platform connects designers, local printers, material suppliers, customers, and various data all simultaneously in both the directions. So, in the demand of this economy scale, the more participants join the platform, the more valuable it becomes for everyone at a zero marginal cost. Companies are moving from resource controllers to ecosystem orchestrators. They no longer need to own the factory, they just need to own the platform. And this is exactly what you will be seeing in the Priya section, because GE Aerospace did not just use 3D printing as a manufacturing tool, they used it to become a platform orchestrator in their own industry. Over to Priya. Thank you.
Hey guys, I'm Bindushree Sahir Priyobini. So we have covered the technology and the patterns. Now let's look at the company that actually did this for real. GA Aerospace, jet engine manufacturers. And over the last decade, 3D printing has changed how they build, how they deliver, and how they make money. It starts with one small part, the fuel nose, inside the LEAP engine. Like a size of a walnut, used to be 20 separate metal pieces welded together, but GE printed it in a one single piece. And here we can see that result means that 25% lighter, 5 times more durable. And because 3D printing lets you create internal shapes and that conventional matching simply can't, the new nozzle is so much more efficient and the whole engine runs 15% better than the fuel, which is the whole process of the new 3D printing. And every LEAP engine has 19 of these. Across the fuel airline fleet, that 15% saving translates to hundreds of million dollars in a year. That's why airlines are choosing GE. This is just one of an example for that. And they didn't just stop there. Their newer GE 9X engine, built for the Boeing 777, which is the world's biggest commercial jet engine in the world, has over 300 printed parts, which also includes blade, mixers, or heat components, these kind of things. And which also means that it's 10% more fuel efficient than the original it replaced. Than the previous engine, it's distributing over 10% more results. And honestly, the gap comes down to one thing, which is 3D printing, making things that weren't possible before. Now, value delivery. Basically, how product gets made and reaches the customer. Traditionally, building a jet engine means coordinating thousands of parts from hundreds of suppliers across the world. One delayed shipment means the whole thing stalls for months. And now, but with 3D printing, just cuts through that. GE now prints 600 of those nozzles every week at one facility in US. And one file goes in and one finished part comes out. That's how 3D printing works. And instead of days or months, we do it in hours. And they put $650 million into scaling this in 2024 alone. That's not a trial run, that's a full commitment. Now, let's see the financial results. And we can clearly see that $149 billion order backlog in 2024. 90% of that is a long-term service contracts, not just engine sales. Decades of recurring revenue locked in. And in 2025, we can see that 45.9 billion in revenue, up by 18% operating profit, 10 billion, and up by 31%. These are the numbers of a company that rebuilt its business model around a technology advantage. And here, what it makes really hard for anyone else to copy. In 2016, GE didn't just start using 3D printing, but they went and bought two companies that are using 3D printing themselves, one in Germany and one in Sweden. So they own the whole thing, the missions, the process, and the knowledge. A competitor wanting to catch up wouldn't just need to learn the technology, but they also need to get every single equipment, single part approved by aviation regulators from scratch, and that take years. That's the real advantage of GE in this industry. So, better products means faster and simpler supply chain. Premium long term revenue, GE use 3D printing not to save a bit of money on manufacturing or supplement, but they use it to build a completely different kind of businesses. And here we can see the value capture, value delivery, and value creation as well.